All right, 3.3 practice. Identify the type of function and describe the transformation from its parent graph. All right, well, this is x to the 1 basically. We don't write 1, but it is 1. So that means it is a linear function. Now there are two transformations going on. This negative right here in front of the x flips it over the x-axis, and the plus 3 moves it up 3. All right, number 2, we have a little 2 up here in the exponent, so that means it's quadratic. Transformations, only one, minus 8, which means down 8. Number 3, absolute value bars, so it's absolute value. That's a horrible S. Two things going on. This 4 right here is going to make it skinnier. And the plus 1 here, remember, inside lies. So instead of going right 1, it's going to move left 1. All right? And remember, the beautiful thing about this is you have a graphing calculator. So even if you're not good at remembering these rules, there's no reason to get these wrong. So for example, number 2, if I just put in x squared, all right, and then I go down here to number 2 and I put x squared minus 8, you will see the parent function, then the transformation. Clearly it just dropped down 8. Now on number 3, the ones with the inside lies are usually a little bit more challenging. So on number 3, we go to math, absolute value, enter, and we just put x. Then we go down here to number 2, math, over to number, absolute value. Oops, sorry. I need to put the 4 in first. Then math, over, absolute value, x plus 1. Now you'll see, there's my parent function, and there's my transformed one, skinnier, and moved left 1. So use the calculator. Number 4. Again, we have the little 2 right there, so it's quadratic. This one has a lot going on. We have the negative, which flips it. We have the 1/3, which makes it wider. We have the minus 2, inside lies, right 2, and plus 4, up 4. So a lot going on with that one. Number 5, we have an exponent here that's got an x in it. The base is bigger than 1, so that's exponential growth. The plus 1 up in the exponent is kind of like follows the inside lies rules. So plus 1 is actually left 1. And the minus 7 is down 7. All right. Number 6. We'll go ahead and put this one in. You can see here's how you put in 2/3. It's just simply 2 divided by 3, x plus 5. And you can see that it is moved up 5. And also it is wider. So again, this is absolute value. Sorry, my pen's being weird. It's wider and up 5. Okay, number 7. Number 7 is a square root. You got the square root symbol there. All right. The negative, again, flips it. And the plus 8 underneath is, again, inside lies. So that's going to mean left 8, and the minus 2 on the outside is down 2. Number 8, a lot going on. This is a quadratic. The 3 halves. Now be careful with this one. 3 halves, remember, it's improper fraction. It's 1.5. So it's not wider, it's skinnier or narrower. The minus 5 inside lies, so that's right 5. And minus 1 is down 1. Last of these, this is exponential. There's an x up in the exponent spot. This is less than 1, which makes it exponential decay. Looks like Doc. All right, minus 4, inside lies. So instead of left, it's right 4. And plus 6 means up 6. All right, this is obviously absolute value. And from 0, 0, it has gone right 1, 2, 3, and up 1, 2. This one is a quadratic, a parabola. From 0, 0, we've gone left 5 and down 4. Left 5, down 4. Right? And this one, this is exponential growth because it's going up to the right over time. Right? And usually this point is right here at 1, 0, 1, so it's gone up 4. All right, identify the type of function and sketch the parent graph. This is important. People lose points on this all the time. Sketch the parent graph. The parent graph is x squared. Put this in your calculator, okay? But it's going to be 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4, 3, 9, and negative 3, 9. Classic parabola. Okay. So this is a quadratic. All right. Now, again, all this down here is based on the transformed one, not the original. So what's happening? Plus 4 means left 4. And minus 5 means down 5. All right. So all that means is this entire parabola is just going to move left 4 and down 5. Like so. You can take each point and just move it left 4 down 5. You can type this in the graphing calculator and just get your points and plot them. Okay, so your vertex now instead of 0, 0 is, negative 4, negative 5, okay. The domain, remember, domain is your x values, range is your y values. Domain is how far left and right. Well, it goes forever left and forever right, negative to positive infinity. And the range, how low does it go? That's right here at negative 5. And it's going to hit that, so we use a bracket, and it's going up towards positive infinity. Okay, number 14. 14 is obviously absolute value. It has the absolute value bars. Okay, and that's basically one that's 0, 0, 1, 1, all the way up to 10, 10. Okay, that's your classic absolute value. Sorry, I meant to hit the pause there. So that's the absolute value. This one has got three things going on. The negative outside is going to flip it. The -2 inside lies means it's going to go right 2, and the +6 means up 6. Okay, so this is one I would definitely suggest you use a calculator on, just to make it easy on yourself. So you go up here, go to y equals. We still have the absolute value there. We're just going to go down to number 2 and clear it out. Okay, and then we're going to put in, use the gray negative key, math, absolute value, x -2 +6. Graph. There's the parent one, which I already did. And here's this one. Obviously, you can see it went right and up and then flipped over. So we go to the table, and we're going to get these points here. Okay? See how it mirrors -3, 3, -2, 2. So it's going to be -7, -3, and -1, +3. So you want to kind of get a little bit of both sides. Okay? So -7, -3. Right there. I'm just going to kind of skip and get a few different points. -1, +3. We're going to get both sides of it. 2, 6. Up here. And then you see after 2, 6, it's going to start coming down. So 4, 4. That's on both of them. And maybe 7, 1. That gives us a pretty good idea of what's happening here. And it's going up there and down there. So this again gives me a hint of where my vertex is. It went up to, right to, up 6. That's my new vertex from 0, 0. The domain, how far left and right, again, negative to positive infinity, is going to go on forever and ever, left and right. My range is going down towards negative infinity. And then my top part is at 6. Now, this one up here, I didn't put both of them because I just physically moved it, but you should have both graphed on there. All right, number 15. This one is going to be at 0, 0. It's a square root. Okay. Square root of 4 is 2, and square root of 9 is 3. That's about all we can do, is those three. Now this one, inside lies, so it's going to be right 3 and down 4. So again, you're just going to, here's what I'll do. I'll just copy it like this and then move that one. So this one is going to literally move right 3, 1, 2, 3, and down 4. Like so. So the vertex is at 3, -4. The domain, how far left is it going? Three. How far right? Infinity. Range, how low does it go? -4. How high does it go? Infinity. It's going to take a long time to get there because it's climbing very slowly, but that's what it's going to do. And these are just some quick review problems. So on this one, the first thing we need to do is get rid of the 2. So we're going to add 2. So that leaves us with the absolute value, 6x plus 5, negative 6x plus 5, equals, add 2, negative 35. Now, at this point, you want to go, oh, I can't solve it. Yes, you can, because you need to divide by -1 to get rid of that. So that gives me absolute value, 6x plus 5, equals 35. Now, at this point, now that this is by itself, we can write it twice, bust it out, and make it equal to 35, and equal to negative 35. So we're going to subtract 5 and get 6x equals 30. On this one, we're going to subtract 5 and get 6x equals negative 40. Then we're going to divide by 6. X equals 5. And over here, x equals negative 40 over 6. And that's okay to have a fraction answer. You should reduce it to negative 20 over 3. There you go. Number 17. First thing we need to do is get rid of that 1. So we have absolute value of x trying to write a minus. X minus 4 over 3. When we subtract 1, we get 2. Now I need to multiply both sides by 3 to cancel that. So that gives me absolute value of x minus 4 equals 2 times 3. 2 times 3 is 6. Now we can bust it up into 2 separate equations. X minus 4 equals positive 6. X minus 4 equals negative 6. When I add 4 to both sides, I get 6 plus 4 is 10. And over here, when I add 4, x equals negative 2.